Let's take a look at this chapter. In our first section, want to plot points on a rectangular coordinate system, use distance midpoint formulas, graph equations about plotting points, identify X and Y-intercepts, and graph equations using the graphing utility. Okay, now plotting points. If we're plotting the point 2, 3, this first part before the comma is our X part. And this second part after the comma is our Y part. Now, rectangular coordinate system, we have our X-axis and we have our Y-axis. Now 2, 3, as my X values go to the right, they increase. So this is 1, 2, 3, 4, and so on. As they go to the left, they decrease. So that's -1, -2, -3, -4, and so forth. Now our Y-axis, as the values go up, they increase. So this will be 1, 2, 3, 4. And as they go down, they decrease. So -1, -2, -3, -4. Now when we want to plot the point 2, 3, we go to the intersection. It's kind of like that old game Battleship, where you look at the intersection of 2 on the X-axis and the intersection of 3 on the Y-axis, and where they intersect is your point. So that point right there would be 2, 3. Now, it says graph equations about plotting points, so let's talk about that first since we're talking about points. If I got y is equal to 2x minus 3, I want to graph it. Well, I had to pick x values. I'll pick 0, 1, and 2. Now it doesn't matter which ones you pick. I wouldn't pick them too far apart. 0, 1, 2, 1, 2, 3, -1, 0, 1. We want 3 points for a line. This is a line because everything's the first power. Now we're going to take each one of those, start off with x equals 0, and we want to plug them into here and solve for y. So we've got y is equal to 2 times 0 minus 3. 2 times 0 is 0, minus 3 is -3. Now our next one, x is equal to 1. I'll plug 1 in for the x. So I got y is equal to 2 times 1 minus 3. 2 times 1 is 2, minus 3 is -1. And then if I plug in my last one, x is equal to 2, I'm going to get y is equal to 2 times 2 minus 3, 4 minus 3, or 1. So then after I get those 3 points, I'll go ahead and plot them. There's 0, -3. Here's 1, -1. And here's 2, 1. And then, well, if I'd been a little bit more careful, you draw a straight line through them, and that'd be your graph. Hi. Can you hear me okay? Can you hear me okay? Maybe not. Let's see if I can send a chat. Let's see. Yeah, where's chat? Now, if you haven't, let me go to. Oh, Can you hear me now? Can you hear me? Have you? I don't know if you can hear me or not. Can you hear me now? You can't hear me, can you? Oh, you can? Oh, okay. I can't hear you though. All it sounds like is a real high wind. But you hear me fine? You hear me just fine then? Oh, okay. Well, I'm probably gonna mute you to shut off the high wind. I know it's not high wind, but it's there. Okay. So let me what I'm going over is parts of chapter 2 here, and I just graphed equations by plotting points. So now I'm going to go over the distance and midpoint formulas. Now let me clear this off. And better scroll up a little bit. Clear that off. Now given 2 points, x1, y1, and x2, y2, then we have a formula for the distance. And it goes like this. We got d is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. Now we also have the midpoint formula. And the midpoint formula says m is equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Let's say I had this problem. I'm given these 2 points here, -3, -2, and -1, 5, and I want to find the distance and the midpoint between these 2 points. Well, first thing I got to do is I got to label the points. This is my first point, so I'll label this as x1, y1. This is my second point, so I'll label this as x2, y2. It actually does not matter which one you specify as your first point, which one you specify as your second point. It works out either way. Then for our distance formula, you probably find it better off to go through and replace all of your variables with parentheses before you plug in your numbers. Now, since there's already parentheses there, I'll make some of them a little bit bigger. And this will be y2 here, this will be y1, and this will be x2, and this will be x1. Well, y2 we said was 5, y1 is -2, x2 is -1, and x1 is -3. Usually where people mess up on the distance formula is on the signs, if they do mess up. So here I see there's a negative, and remember that gives you a positive. So we got 5 plus 2 squared plus -1, and over here we have a negative. And that gives us a positive 3, and then all that squared. Now 5 plus 2 is 7, so we got 7 squared plus -1 plus 3 is 2, so that's 2 squared. 7 squared is 49 plus 2 squared, which is 4, which gives us square root of 53. Now I believe that's prime, so that'd be our answer. Now, second thing we're going to find given these points is the midpoint. And there's probably no need to put any extra parentheses in for the midpoint formula. I think nobody really ever messes up on the signs on it, because it's a lot easier formula. You just add together your x parts divided by 2, and you add together your y parts divided by 2. So we got -3, -1 divided by 2, and we got -2 plus 5 divided by 2. -3, -1 is -4, so we got -4 over 2. -2 plus 5 is 3, so we got 3 over 2. Which gives us -2 and 3/2. Now distance is the distance between those 2 points, and the midpoint is the point exactly in the middle of those 2 points. Now that you get that written down before I continue on. Okay. Okay, so we showed plotting points, distance, midpoint formulas. We graphed equations about plotting points. Now it says identify x and y-intercepts. If they mean the graph, all they want you to do is look at the graph, and your x-intercept is where it crosses the x-axis, and your y-intercept is where it crosses the y-axis. Let me make this a little bit bigger. So x-intercept. This is where the graph, and I'm going to put crosses or touches the x-axis. And the y-intercept is where the graph crosses or touches the y-axis. We'll see later on in the course Whether it crosses or touches actually has different meaning when we're talking about graphing and multiplicity and how many zeros we have. Now I'm not going to show an example of identifying the x-intercept or y-intercept based upon the graph. I think that's pretty straightforward. But I will go over how do you find the x-intercept or y-intercept algebraically. So finding the x-intercept. And I'll put an S on here because you can have more than one. Step 1, plug 0 in for y. And step 2 is solve. The intercepts are always the same. You always plug 0 in for the other variable and then you solve. Now finding the y-intercept. First thing we'll do is we'll plug 0 in for x, and then we'll solve. So again, the same idea. You plug 0 in for the other variable, and then you solve. Now since we're specifically talking about lines in this chapter, I'm going to focus on showing two examples, or actually one example involving a line. If I had 2x plus 4y is equal to 8. And instructions were to find the intercepts. Well, find our x-intercept. We always plug 0 in for the other variable. So I'll plug 0 in for y. So I got 2x plus 4 times 0 is equal to 8. And then step 2 is to solve. Well, 4 times 0 drops away, so we got 2x is equal to 8. And then we divide both sides by 2. And we end up with x is equal to 4. Now, more than likely, what Alex wants is a in point form. So this would be 4, 0. And that would be our answer. Now for our y-intercept. Same instructions. Step 1, you plug 0 in for the other variable. So plug 0 in for x. So I got 2 times 0 plus 4y is equal to 8. And then step 2 is I want to solve. Well, 2 times 0 drops away. So I got 4y is equal to 8. And then I divide both sides by 4, the number that's in front of my y. And we end up with y is equal to 2. And again, more than likely what Alex wants is the point form of that, which would be 0, 2. And those would be our x-intercept and y-intercept. Now skipping ahead a little bit, when we get to the linear equations and graphing those, one method of graphing when you got lines is to plot the intercepts. 4, 0 would be right there, and 0, 2 would be right there. And then after you have your intercepts, you draw a straight line through them, and that would be our graph. Some people prefer that method versus using a T-chart. Now, last thing in this section is graph equations using a graphing utility. And I'll just cover a little bit of this. I won't spend a whole lot of time on it. There's a YouTube video that'll show you all in depth more of how do you do it on graphing utility. Let me clear this off. And this is a T83, T84. And I'm going to look at some basic graphs. Not all of them, but I'll look at enough so you get the idea. These are going to be some basic graphs, so we'll see again later in this chapter when we talk about transformations. So I'm going to look at y is equal to x. I'll look at y is equal to x squared. Y is equal to x to the third. Y is equal to square root of x. Y is equal to cube root of x. And y is equal to absolute value of x. Now after we look at these graphs here, I'm going to skip down to section 2.6 and talk about transformations of graphs, because it goes hand in hand with these basic graphs I'm just looking at. Okay, our first one, y is equal to x. I'm going to press my y equals button. I'm going to press my clear button. I'm going to press my X key button. And then I'll push my graph button. And that should give us our straight line going through like that. Okay. You may not have a TA3, TA4. And if you don't have a TA3, TA4 and you're going to plot points to see what the graph looks like, you generally have to know what is the shape of this. And when you have y to the first power and x to the first power, it's always a straight line. So that gives you an idea. If you have plotted some points in your t-chart and you got a straight line, that means you found a graph. On the TA3, TA4, I press my y equals. Now when I push the clear is right over here. It clears out whatever's on the line. Now I put X key down here, and that would be this X right here. And then I push graph, and that gives me my graph. Anytime you can get y by itself, you can plug it into the calculator. Now y is equal to x squared. That's going to be y equals clear. Then we'll put our X key in. And then we'll do our X squared button. And then we'll do our graph. And what that'll give us is the U-shaped graph, the parabola. The x squared is always your U-shaped graph. So on this one, if I press my y equals, press clear, it'll clear out whatever's in that line. I push my X key button. Now it's too hard for me to write X, T, theta, little n each time, so I'll just write down X key. And then I'll push my X squared button. The X squared is right here. Now the X squared button does not put this X on there for you. All it does is put the squared on there. And then you push the graph. And again, that gives you a U-shaped graph. Now the y is equal to x to the third. If I do y equals clear, and then I do my X key, and then the caret, and then the 3, and then the graph button. It gives us that graph right there. Now the caret. If I press my Y equals, press clear. I do my X key. The caret is right over here below the clear, and it puts the power on there for you. Now in the near T84, it puts it up in exponent mode, and then you do your 3. And if you do have one of the newer T84s, you have to press the right arrow key to get out of the exponent mode. And then I push graph. And gives you more or less this. I'm not very good at sketching. Now square root of x. If we press Y equals, clear. To get to the square root, you have to do your second button, and then you push your x squared. And then you do your X key, and then you do your graph. And the square root would look like this right here. So I press my Y equals, clear. Square root, I do second x squared. It puts a square root on there, and then I put my X key. You don't have to put closing parentheses at the very end on a TA3, TA4. It's very forgiving about that. And then you just simply press graph. And this is why if you're plotting points, it's nice to know what generally the graph's going to look like. So you can plot enough points to get the look. Now the cube root. If I push my Y equals, press my clear, then I go to the math button, and I want to choose, I think it's the fourth one. We'll see in a minute. And then I'll do my X key, and then I'll do graph. What that'll give you is that graph more or less. Okay, so if I press my Y equals, press my clear, I go into the math button, and I see the cube root is the fourth one. So I can down arrow to it and press enter, or I can simply press the 4 that's in front of it. And it chooses the cube root, then I do my X key, and then I do my graph. Now our absolute value. So press my Y equals, press my clear, I go into the math button, and then I want to right arrow to num, and I want to do an enter on ABS, and then I'll do my X key, and I'll do my graph. And that gives us our V-shaped graph. So if I go to graph this, press my Y equals, press clear. I do my math. Now when I say right arrow to num, across the top you see it says math, num, CPX, PRB. If I right arrow, that'll take me to the num menu. Now ABS is already highlighted, so when I say enter on ABS, I'm just simply saying press enter. And then you do your X key, and then graph. And that's our V-shaped graph. Now I'm going to erase all those. And that's the end of the first section. And I'm going to skip down to section 2.6, transformations of functions. Now recognize basic functions. Well, those are the 6 we just looked at. So those are our basic functions. Now let's talk about some of these shifts and some of these different items that happen. I like to do these by example. So if I have y is equal to x squared minus 3, if you remember, the x squared is our U-shaped graph. When you got a number at the very end or a number at the very beginning in terms of addition and subtraction, this is going to shift it up or down. Since this is a minus 3, this is going to be down 3. Now what that means, graph-wise, is if I have x squared like this, my parabola, it'll still look like that, just the entire graph is shifted down 3 units. So it hasn't changed anything of how it looks, just shifted it down 3. Now the beauty of the transformations is you can very quickly sketch the graph without picking up a calculator. And they apply to any of our basic graphs. If you remember the absolute value, that was the V-shaped graph. And if the negative 3, the minus 3, is down 3, then we got a positive here. And that plus 2 or positive 2 means it's going to go up 2. Now here's our basic graph we looked at, the V-shaped graph. When I say up 2 units, I'm going to shift the entire graph up 2 units. It still looks exactly the same as it did, I just shifted it up. Now those are our vertical translations. We also have some horizontal translations. If I have y is equal to x minus 1 squared. Instead of the number being at the very end or the very beginning, let's say the number is inside with the x. This is going to shift it left or right, opposite what you think. Well, the minus 1 makes us think left 1, so that means this is really going to be shifted right 1 unit. Remember, our x squared is our U-shaped graph. And when I say shift it right 1 unit, it'll look like that. If I had, let me pick on the absolute value again, something look like this. Now I said the minus 1 would shift it right 1. Well, here's a positive 4. Now that would make us think it goes right 4, so it's really going to go left 4. It's opposite what you think. Now here's our V-shaped graph. It's still going to look exactly like that V-shaped graph. We're just shifting the entire thing left 4 units. Now let's talk about reflections. We got y is equal to negative x squared. Now this particular one occurs whenever you have a negative out in front. What does that mean, out in front? Well, out in front of the x squared, in front of the absolute value, in front of the square root, or whatever. This is going to reflect across the x-axis. So that's going to reflect across the x-axis. Well, remember our x squared is our U-shaped graph. For purposes of the U-shaped graph, when I say reflect across the x-axis, it basically flips it upside down. So it looks like that right there. It's a little bit more than that. Reflection means that it's kind of like an axle in a car. You rotate the entire graph. Though in most cases it'll look like you just flipped it upside down. Now instead of the number being, or the negative being out in front, you may find some problems the negative is inside with the x. What does that mean, inside? Well, it could mean inside the parentheses, inside of the square root, inside the absolute value, inside of the cube root, inside of whatever. This is going to reflect across the y-axis. Now there's our square root of x, and when I say reflect across the y-axis, it flips it over in this direction. Now I don't know what problems Alex have on this. Some of these get kind of challenging, where they give you a function, but the function may consist of just points. So you have maybe points, like 1, 3. And then they ask you to apply transformations. And this is where you really have to think about, what does that mean exactly? See, like if I'm talking 1, 3, that'd be right here. Now I said if you have a negative out in front, that flips it across the x-axis, reflects it across the x-axis. Which means that this point down here would be right down here. And this would be the point 1, negative 3. So you can see that a negative, when I say it flips across the x-axis, reflects across it, changes the sign of your y value. So the best way to do it on these, I think, is to plot a points and think exactly what it's talking about. If it asked me, take my f of x plus 3. Well, you have to remember what the f of x represents. The f of x is the same as y. So this is saying I'm going to add 3 to my y component. So the original point would become 1, 6. I added 3 to the y component. So it's a little bit challenging to think about how does that affect the points. Sometimes you have to graph it, like my first example here. Sometimes you just maybe can think it through, and you can see what it's referring to. I'm going to go ahead and erase those. Those are basically our transformations. And usually I go for an hour and a half on a lecture, and then I answer any questions. Since I can't hear you, then at that point, if you just email me your questions, then I'll bring those up and I'll answer any questions you have from the email. So not exactly interactive, but okay. Let's go back up here to circles. It says write an equation of a circle in standard form. Now for a circle, Our standard form looks like this. We got x minus h squared plus y minus k squared is equal to r squared. Now h, k, and r are numbers. And if you have in that form, your center is going to be hk, and your radius is going to be r. Now let's say we're given a center, negative 3, 5, and r is equal to 2. Now the implication here is, it says write an equation of a circle in standard form. So we're going to plug these in for the appropriate variable. When you're given a center, you're given h, so they're telling us h is negative 3. And you're also given k, so they're telling us k is 5. Now our standard form is x minus h squared plus y minus k squared is equal to r squared. So I'll plug in the appropriate number. So h we said was negative 3 plus y minus k, which was 5, equals r squared, so 2 squared. Then you do a little bit of simplifying. X plus 3 squared plus y minus 5 squared is equal to 4. And that would be our answer. Now the second thing they're asking us to do in this section is to write the general form of an equation of a circle. That's kind of vague what that's implying, so I'm going to show you two different ways. One of them is if you have it in this form, standard form, general form typically means you get rid of parentheses, so let's do that first. So x plus 3 squared means x plus 3 times x plus 3. Y minus 5 squared means y minus 5 times y minus 5. Then I'll FOIL these. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. Plus y times y is y squared. Y times negative 5 is negative 5y. Negative 5 times y is negative 5y. And negative 5 times negative 5 is 25. And I'll bring the 4 over to the left side. Okay, get rid of parentheses. General form usually means put the squareds together. So I got x squared and y squared, and I'll put those first. Then you put the first powers next. 3x plus 3x is 6x. Negative 5y is negative 10y. And then you put the numbers at the end. Of course, I'm going to combine them together. 9 minus 4 is 5, plus 25 is 30. And this is one variation of general form. Some books, and it seems like everybody has their own ideas on this. Some books, general form means you don't have any fractions. So you'd multiply everything by your LCM of all your denominators. Some books indicate that you cannot have a number in front of your x squared or y squared, which means you'd have fractions. So I wish there was a specific standard on that, but there isn't. But that's on general form. Now, more than likely, they'll probably have a problem where they give it to you in general form. Like this right here. So we start out here, and they want us to put it back into standard form. So circles changing from general form to standard form. Now step 1, I'm going to divide everything, all the terms, by the number in front of the x squared. Step 2, group the x's, group the y's, take the number to the right side. Step 3, complete the square on the x's and complete the square on the y's. So if I did have something in this form, and first step says divide everything by a number in front of the x squared. Well, there is nothing in front of our x squared, so we don't have to do that. Step 2, group the x's. So I'll put the x squared next to the 6x. Group the y's. So I'm going to put the y squared and the negative 10y together. And take the number to the right side. So I take 30 over, and it becomes a negative 30. Now step 3 says complete the square on the x's. And what we do with the completing the square on the x's is we take the number that's before x, which is 6, and we multiply it times a half and we square it. It's always times a half and it's always squared. Now 6 times a half is 3, and 3 squared gives us 9. And then we want to add that to both sides. So I got x squared plus 6x plus 9. And over here I'll have negative 30 plus 9. Now step 3 also says to complete the square on the y's. So we'll take the number that's in front of our y, which is negative 10, and we multiply it times a half and square it. It's always times a half and it's always squared. Negative 10 times a half is negative 5, and negative 5 squared gives us a positive 25. And then you add it to both sides. So I'm going to add it to the y group over here, and I'll add the 25 over here. Now we want to factor the x's, so the x group. So I'm going to factor this as x plus 3 squared. We want to factor the y's, so this will be y minus 5 squared. And 9 plus 25 is 34, minus 30 gives us 4. Now how I factored that so fast, there's a trick to it. Whatever number's in your parentheses right here, right before you squared, is always what goes down right here, sign included. Over here, whatever number's inside your parentheses right here, right before you squared, sign included, is always what goes right here. So there really is no factoring involved there. And you notice that this right here matches our original standard form. So that shows you how to go back and forth between general form and standard form. And given a center and radius, how to come up with the standard form. Okay. let's take a look at, that was section 2.2. Section 2.3 is functions and relations. And first thing we'll do is just talk about generally what a function is. Now, a function, definition of function says for every x, there is only one y. That's a very hard definition to work with. The only time it works well is when you're dealing with points. So we got an easier definition. And it says, if you have one of the following, it is not a function. If you have y to an even power, if you got the absolute value of y, or if you got the plus or minus symbol. There's actually a little bit more than that. You got x is equal to a number, it's not a function. Like x is equal to 3. And there's still even more than that, but those are the real common ones we run across in algebra. You'll have some problems that just ask you to say if it is a function or not, if it represents a function. Now when I say it, I'm talking about you'd have a problem. Let me clear this off. You might have something that looks like this. Y is equal to x squared. Or you might have y squared plus x is equal to 3. And the question is whether these represent functions or not. Well, if I go look these up, I said if you have any of these, it's not a function. So these are our bad items. Y is equal to x squared. Well, we can have x squared, we just can't have y to an even power. And it doesn't have any of these other items, so it's fine. This would be, yes, this is a function. But on our second example, see how it has a y to the second power? We said you cannot have y to an even power. So the fact that it has a y to an even power on this one means no, it's not a function. Now we have something called a vertical line test. And this says if any vertical line intersects the graph at 2 or more places, then it is not a function. Excuse me. Usually this entails them giving you a graph to begin with and asking whether it's a graph of a function. Typically they don't ask you to graph it because if it's not a function, it's very difficult to actually graph. Thinking homework wise. So over here, what you would see is where they give you a graph like this, and they ask you if it's a graph of a function. Well, you drop a vertical line here, it intersects one place, drop one here one place, drop one here one place. There's no place I can drop a vertical line where it intersects at two or more places. So this one is a function. The answer here would be yes. On the other hand, if I had this graph right here, if I dropped a vertical line right here, it would intersect at two or more places, which means this one's not a function, or the answer would be no. This particular graph here is a graph of y is equal to x squared, and we said that they didn't have any of those bad items on it. This one is actually the graph of x is equal to y squared. And notice how it has y to an even power. So that even power goes hand in hand with failing the vertical line test. Now we have something called function notation. And it has two purposes. One is to give a name. When we're looking at graphing or other items where we have y is equal to 3x minus 1 and we got y is equal to 4x plus 5. If I ask you to graph y, well, your question would be, well, which one? There's two of them. Well, instead of calling them y, we give them a name. Now, the names we give them are not like Bill and Bob and so forth. The name looks like this. And how you read that is that's read as f of x. Or we even get lazier in math and we just call it f. On this one, we may give it the name g of x. Or we even get lazier in math and refer to it as g. Now, our function notation is interchangeable with y. So if you have a y there and you want to put function notation, that's fine. If you have a function notation and you want to go back and put the y, then that's fine. Now, there's no mathematical meaning there. That does not mean f times x. That is strictly just telling it a name, giving it a name. Now, we have a second purpose for function notation, and that's to reduce writing. You had problems back in maybe previous courses that said evaluate y is equal to 3x minus 1 for y when x is equal to 5. And how you solve this is you went through and you put 5 in for your x. So you got y is equal to 3 times 5 minus 1, y is equal to 15 minus 1, or y is equal to 14. And that'd be your answer. Now, instead of writing all those words down, we can simply say f of x is equal to 3x minus 1, and then we'll say find f of 5. That notation right there says the exact same things as these words over here. It's just a very concise way to write that. A lot of times mathematical notation is just a very shortened way of expressing whatever you're trying to find. Now, it still worked the same way. F of 5, we plug 5 in for the x. We get 15 minus 1, or we get 14. So that hasn't changed, it's just reduced the writing. Now, this is referred to as evaluating a function. You may have heard the other way referred to in different manners. One way they refer to is evaluating an algebraic expression. Sometimes they say evaluating an equation. There's different ways that books will write this. Now let's take a look at evaluating a function. See the steps for it. I was just pausing for a minute. I had a message saying my internet connection's unstable, which means I was probably cutting in and out on your side during that time, so that's why I paused. Evaluating a function. Step 1, replace all variables with sets of parentheses. Step 2, plug in whatever we are evaluating for into the parentheses. And then step 3 is to simplify. Okay, so let's take a look at an example. Let's say we got f of x is equal to 9x plus 3. And we want to find f of 5. This is just going to do some notation, and I'll show you a little bit more exciting example in the next one. Now, whatever's inside of our parentheses, this is referred to in my instructions as whatever we are evaluating for. You can see why I try to type as much as I can. My writing isn't very good. Okay, step 1. Replace all variables with sets of parentheses. So we're going to go through, and everywhere we have a variable, we'll put it in parentheses. Step 2. Plug in whatever we're evaluating for into the parentheses. So whatever's inside the parentheses right here is automatically what you're going to put in these parentheses. Well, we got a 5 here, so we're going to put a 5 here. And then step 3 is to simplify. Well, 9 times 45, or 9 times 5 is 45 plus 3 gives us 48. And that's our answer. Like I say, that wasn't a very exciting one, so let's look at one a little bit more interesting. X squared minus 2x plus 7. And let's say we're going to find f of x minus 1. Step 1. Replace all variables with sets of parentheses. So we're going to have parentheses squared minus 2 times parentheses plus 7. Notice how everything else remains exactly the same. All I did is replace the variables with parentheses. Step 2. Plug in whatever we're evaluating for into the parentheses. So whatever's inside the parentheses right here is automatically where we're going to plug in here and here now. So put an x minus 1 here, and we'll put an x minus 1 here. When I run across evaluating functions, I don't even think them through. I'm thinking through these 3 steps every time I work them. Now step 3 is to simplify this. And x minus 1 squared means x minus 1 times x minus 1. Now here I can use the distributive property. Negative 2 times x is negative 2x. Negative 2 times negative 1 is a positive 2, plus 7. FOIL this. X times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is negative 1x. Negative 1 times negative 1 is a positive 1. Minus 2x plus 2 plus 7 is 9. Combine like terms. We got negative 1x, and negative 2x. That gives us negative 4x. And combine numbers. We got 1 plus 9, which gives us 10. And that would be our answer. Let's see. We talked about determining the x and y intercepts in the previous section. Now let's talk about it's presented here, but it's kind of spread throughout, where it talks about finding the domain. So let's take a look at finding the domain of a function. First off, I'll define what a domain and range are, and then I'll look specifically at us finding the domain. Now, domain is your x values where your graph exists, and your range is your y values where the graph exists. Now, domain and range are a lot more than just x's and y's. Domain is the kind of the driver, if you think of it. For example, if I want to eat out Chinese food tomorrow, the amount of money I have in my wallet would drive what restaurant I go to, whether I go to a cheap restaurant or whether I go like to a PF Chang's type restaurant. So the domain, the important part is the money. If I don't have any money, then I'm not even going to the restaurant. The range is the one that's being driven. So in our example, the domain would be the money in my pocket. The range would be the specific Chinese restaurant I want to go eat at. Now, domain is the more important one because, like I said, if I don't have any money, I can't go out and eat. So you'll find a lot of times when you're talking about functions, their main focus will be on the domain because the range is just driven by the other one. The best way to get to range is you look at the graph and see where your graph exists y value-wise. Okay, so domain by default is all real numbers except ones that cause a denominator to equal 0 or ones that cause a negative number inside of a radical with an even index. Now, if we want to take a look at finding the domain where you got a fraction, specifically with a variable in the denominator. Step 1, set the denominator equal to 0. Step 2 is solve. And then step 3, put a slash through the equals. So for example, if I had f of x is equal to 2 minus x over x squared minus 5x plus 6. And the instructions were to find the domain. Well, step one. We got a fraction with a variable in the denominator. Step one. Set denominator equal to 0. So I'm going to set x squared minus 5x plus 6 equal to 0. Now step 2 is to solve. Well, we would factor this. So this is factors as x minus 2 times x minus 3 equal to 0. And then we use a zero factor property. This book calls it something different. They call it a zero product principle. But if you get 0 on one side and you factor the other side, you set each factor equal to 0. So I'll set x minus 2 equal to 0 and x minus 3 equal to 0. And then you solve for x. So take negative 2 over, take negative 3 over, and I get x equals 2 and x equals 3. Now these are the values that you cannot have. So step 3 says put a slash through the equals. So x cannot equal to 2 and x cannot equal to 3. If I were to put 2 back up here in my original problem, that's one that causes me issues. Now all I really care about is the denominator. I don't care about the top part. Now the book will probably, or the ALEC system might have you write this in interval notation. So let me talk about how that goes. It goes from negative infinity to your smallest value, union, my smallest value to my largest value, union, my largest value to positive infinity. This is how it would say in interval notation that x cannot equal 2 and x cannot equal 3. Now the second type of domain problem that you run across is where you have a domain of a radical with an even index. And your first step is to set what is under the radical, radicand, greater than or equal to 0. And then step 2 is to solve. So in this example here, I would set what's underneath my radical, which is 3x minus 1, set it greater than or equal to 0. Now this is a radical with an even index. Your index is whatever number is in the slot right here. And if there is no number in that slot, it's by default 2. And then step 2 is we want to solve. So I take negative 1 over, becomes a positive 1, divide both sides by 3, and we got x is greater than or equal to 1/3. It's possible that they'll want that written in interval notation, and we would have a bracket 1/3, comma, positive infinity. Now the bracket is because there's a line underneath here. That bracket means it includes that value. So when you have a greater than or equal to, when you have the equal part, you have to put the bracket on it. But that would be our interval notation. Okay, now these next two sections, section 2.4 and 2.5, I'm going to work them together because they're kind of the same concept. So let me clear this off. We're talking about lines. And the first concept we'll look at is slope, which says given 2 points, x1, y1, and x2, y2, then your slope is going to equal to y2 minus y1 over x2 minus x1. And slope is your change in y over change in x. So if I had these 2 points here, and I want to find the slope between them, well, first thing we want to do is we want to label our points. This is my first point, so I'll label this as x1, y1. This is my second point, so I'll label this as x2, y2. Just like the distance formula, it's a good idea to go through and replace all of your variables with parentheses before you plug in your numbers. Sometimes it's helpful, sometimes it doesn't do anything. Now y2 we said was -1, so I'll put a -1 there. y1 we said was 7, so I'll put a 7 there. Now x2 is -2, so I'll put a -2 there. And x1 is 3, so I'll put a 3 there. -1, -7 is -8. -2, -3 is -5. So m is going to equal to 8/5. Now we have something called slope-intercept form. And that's when it looks like this. We got y is equal to mx plus b. You could equally have f of x equals mx plus b. Now if you have it in this form, whatever number's in front of your x, that's your slope. So your m is your slope. And your number at the end, the b, is your y-intercept. Now you may have some problems that give it to you in slope-intercept form, and then they want you to identify the slope in y-intercept. That's very easy. You may have some problems where you have to solve for y first before you can identify the slope in y-intercept. But again, slope-intercept form means you got y by itself on the left side, and everything's the first power. Now we're going to be finding equations of the line and putting them in the slope-intercept form. And these are given conditions. So finding the equation of the line given conditions. Now our first step is to find m. Our second step is to plug in the given point for x and y and m from step 1 into y equals mx plus b and solve for b. And step 3 is to write our answer. Plug in m from step 1 and b from step 2 into y equals mx plus b. One particular example you may have is where they give you the condition, something like they tell you slope is 1/3 and it passes through the point 5, negative 1. And they ask you to find the equation on the line. That's interesting. Nice green. Not sure what happened there. Step 1, find m. Well, m's given here, so that's easy. In the next example, I'll show you finding m given that formula we looked at earlier. Step 2. It says plug in a given point for x and y. When they give us a specific point, they're giving us an instance of x and y that we can use. So I can plug 5 in for x, and I can plug negative 1 in for y. So negative 1 is for the y. M we just said was 1/3, so I can put that in. And x is 5 plus b. And then it says, and solve for b. So we're going to solve this for b. 1/3 times 5 gives us 5/3. Take 5/3 over to the left side, we get negative 1 minus 5/3 equals b, which gives us negative 8/3. A lot of people forget step 3. Step 3 says to actually write your answer down, because we haven't wrote our answer down yet. So step 3, write your answer, plug in m from step 1 and b from step 2. So now that we found m, we're going to plug that in. So we got y is equal to 1/3 x, and we found b, which is negative 8/3. So those would be our, or that would be our answer. Now a different problem might tell us that given 2 points, find the equation line that passes through those points. It's still the same steps. So step 1 was to find m. Well, remember we got a formula when you're given 2 points to find m. So this is our first point, so I'll label this as x1, y1. This is my second point, so I'll label this as x2, y2. And remember our formula is m is equal to y2 minus y1 over x2 minus x1. So I'm going to go through and put parentheses in everywhere I have a variable before I plug in my numbers. Now y2 we said was 7, y1 is 3, x2 is negative 5, and x1 is negative 2. 7 minus 3 is 4. Down here we got a negative negative, which becomes positive, so negative 5 plus 2. Negative 5 plus 2 gives us negative 3. So that would be our slope. Now step 2. We want to plug in the given point for x and y and m from step 1 into y equals mx plus b and solve for b. Now again, when they're giving you a specific point, they're giving you an example you can use to help you figure out what b is. Now here we got 2 points. It doesn't matter which one you pick, whichever one looks easier to you. So I'll plug this in for x, I'll plug this in for y. So I got 3 here. M we just said was 4 over negative 3. X was negative 2 plus b. And then we want to solve for b. Well, negative negative gives us a positive. 4 times 2 is 8, so that gives us 8/3. Now I want to solve for b, so I got 3 minus 8 over 3 is equal to b. And this would give us 1/3. I'm just using the mixed number rule there. What I'm doing is I'm taking the number that's out in front, 3, multiplying it times my denominator. 3 times 3 is 9. And then I'm adding a negative 8 up on top. 9 minus 8 gives us the 1. And then the denominator stays as is. Now step 3 says to write your answer. So we want to plug in the m we found in step 1. So we've got y is equal to negative 4/3 x. In the b we found in step 2, which was 1/3. And that would be our answer. Now that isn't all the topics from these, so it's kind of hit and miss. We covered 2.6, didn't get to 2.7 and 2.8, but I have YouTube videos out there that actually go in a lot more depth than what I'm showing here. So I'm going to go ahead and stop the recording.